What did we learn in our previous class? Let's tell me. Everyone, turn on the video. Karan, Muhammad, Akita.
Rational numbers and decimal expansion.
Okay, fine. Can you just elaborate it again? Can you explain?
I'm sorry. Terminating and non-terminating decimals.
Yes. Given a rational number, okay, you will be given
Yes.
some rational number, and you have to check if that rational number is terminating or non-terminating without using long division method. Correct? And how do we check?
Yes,
You have to express it in P by Q form, correct? And convert that Q in terms of the powers of 2 and 5. 2 power m and 5 power n. If it is possible, then it's a terminating decimal expansion. If it is not, then it's a non-terminating decimal expansion. Okay? Clear?
yes, ma'am.
Mohammed?
Yes, ma'am. 1 minute. I got.
Yes, I told you to
Do
turn
we
on.
have any deleted question?
Yes, Karan, what is it?
And do we have any deleted question this year?
No. Not exactly. Not now. Maybe if you, like, if this corona still continues to be there like this, then we'll see in future. Okay. As of now, no. Right? Because as you know, like last year, we had like so many, like the effect of corona was so intense. There were no proper classes conducted for the students and no proper like tests conducted at school, correct? No midterm, no preparatory exams conducted. That is why the syllabus was reduced last time for 10th standard. This time, we don't know. Let's see. Okay. It all depends on the corona. Right? Yeah. Anyhow, like even if it is like deleted or not deleted, let's continue the normal classes and normal chapters. We'll go with all the chapters. Okay. Yeah. Fine then. Only these many students today. What about others? Puneet, Prajwal. Any idea? Current Puneet or about Puneet and Prajwal?
I'm out from today morning. I've just come now.
Okay. Because today, I thought of explaining some important topic. That's a theorem. And by that, we will be completing the first chapter today. So what do? We'll continue with the class or we'll wait for some time? Who else has to come? Okay. Anyway, we'll continue with the class. Okay. If they are late, then they can watch the video. We can, however, we'll be uploading it. They'll watch the video. Okay. Fine. Okay. Let me share my screen. You people can see the white screen, right?
Yes, ma'am.
Yes, ma'am.
As I told you, today we'll be learning a few theorems. Few in the sense that there are only two important theorems, and using that theorem, we'll be solving other questions. Okay. So the first theorem. I'll give you the statement first. Write down the statement. Let P be a prime number if P divides A square, then P divides A. Where A is a positive integer. This is the proof. Okay. If like we will have a, let's have a P, okay, and that P is a prime number. And if P divides A square, then P also divides A. And what is that A? A is some positive integer. Okay, let's see the proof for it. So as I told you, A is a positive integer, correct? So the prime factorization for A is given by A is equal to P1 into P2 into P3, and it goes on up to Pn. Okay, because P is a prime number, so the prime factorization is given by P1 into P2 into P3 up to Pn. Okay, and now what we'll write is we want A square, correct? So we'll write A square for it. A square is nothing but we'll multiply whatever the value of A 2 times. So it's P1, P2, P3, and so on up to Pn into P1, P2, P3 up to Pn, which is nothing but P1 square, P2 square, P3 square up to Pn square. Clear? Clear till here? Any doubts?
Ma'am, I have a doubt, ma'am.
Yes, sir.
Ma'am, what is Pn, ma'am? If ma'am, it is ma'am, Pn is infinity, ma'am.
You can take up any value. Okay.
Okay, ma'am. Okay, ma'am.
If there's nothing but the positive integer. See, if n is taken as 5, then it will go on up to P1, P2, P3, P4, and P5. It will stop at 5. Okay.
Okay, ma'am. Ma'am, another doubt, ma'am. Ma'am, should we write P capital or small, ma'am, or doesn't matter?
You write small p because here in the statement of the theorem, I have taken small p here. See?
Okay, ma'am.
Correct?
Yes, ma'am.
That
Yes,
is
ma'am.
whatever is given in the statement of the theorem, use the same thing.
Yes, ma'am.
Change. If you use capital P in your theorem, use capital P in the proof.
Okay,
Okay.
ma'am. Yes, ma'am.
Understood? Any other doubts?
Yes, ma'am. No, ma'am.
Okay. Next. It is given that P divides A square. Correct? It is given that P divides A square. So from the fundamental theorem of arithmetic, it follows that P is one of the prime factors of A square. Correct? From fundamental theorem of arithmetic, P is one of the factors of A square. Did you understand this? For example, I'll give you an example for this. Let's say A is equal to 24. Let's say A is 50. Okay, then what are the prime factors for this 15? 3 into 5.
Yes, ma'am.
Correct. Now, what is A square? A square is 225. Is it not? A square is nothing but 15 square, which is 225. Yes or no? Hello?
Yes, ma'am.
Yes, ma'am.
Can you hear me properly? Are you
Yes, ma'am. Yes, ma'am.
Yeah. So
I can
A
hear you,
square
ma'am.
is 225, correct? So now what are the factors
Yes,
for
ma'am.
225?
Ma'am,
Tell me.
545 is
5 into 45 is 225.
yes, ma'am.
Okay,
25
and again, 45 is 9 into 5. So it will be 5 into 5 into 5 into 3. Just a second. Five into 45. This 45 is
Ma'am, 5 square, 3 square.
yeah, 3 square. Okay. So 5 into 5, then 3 into 3. Correct? So, according to this, if P divides A square from fundamental theorem of arithmetic, P is one of the factors of A square. Let me consider this as P1 and P2. Correct? So, you can also see this P1 and P2 are the factors which are present for A square also. Correct? You have 3 and 5 in 225 also for the factors for 225.
Yes, ma'am.
That is the meaning of this sentence. Correct. If P is the factor of A square, then obviously P divides A square. Correct. That's it. Simple. Okay. If P divides A square, then obviously in turn P divides A as well. Clear? Do you want me to repeat again? Guys, tell me yes or no.
No, ma'am.
Pawan,
No.
Arpita,
No, ma'am.
No, ma'am.
Mohammed,
Ma'am, I didn't understand, ma'am.
who didn't understand?
Muhammad, ma'am.
From where you have not understood?
Ma'am, that example one, ma'am.
This example,
Yes, ma'am.
till here you have understood? A square is equal to P1 square plus P2 square plus P3 Pm square.
Yes, ma'am.
Yeah. Then in the proof they have given that P divides A square. Correct?
Yes, ma'am.
Do you remember fundamental theorem of arithmetic? What is fundamental theorem of arithmetic? It is nothing but a natural number can be expressed as a product of prime numbers. Correct? That's a fundamental theorem of arithmetic. So from that we are using that concept and trying to tell is what is P is one of the factors of A square. If P divides A square, then P is one of the factors of A square. Because if it is a factor, only then it can divide a number. For example, what are the factors for 6? 2 into 3. Correct?
Yes, ma'am.
So, if 2 is a factor of 6, it can divide 6. Yes or no?
Yes, ma'am.
That is the concept here. If P divides A square, then P is a factor of A square. If 2 divides 6, then 2 is a factor of 6. Understood?
Yes, ma'am.
Clear?
Yes, ma'am.
That's it. Simple. Then we have already proved that if P divides A square, then P is one of the factor of A square. And since we are using the fundamental theorem of arithmetic here, P is considered as a prime number. And hence it is true. Clear with this?
Yes, ma'am.
Any other doubts? Any one of you? Arpita, Puneet,
No, ma'am.
No, ma'am.
fine with this?
Yes, ma'am.
Yes, ma'am.
Okay, fine then. Did you make a note of this, guys?
Yes, ma'am.
Okay. Shall I delete this?
Yes, ma'am.
We have got next theorem. Theorem 2. We have to prove that root 2 is irrational. This is very important. Sometimes you may, in exams, you may get instead of this root 2, they ask you to prove root 3 as a rational or root 11 as a rational. Okay, you have to follow the same procedure. No changes at all. Okay, we'll start. So whenever you are proving this root 2 as an irrational number, first thing what we assume is we assume the contrary statement. Contrary is nothing but the opposite of it. Here what we need to prove is 2 is irrational, correct? But in our proof, we start with by considering root 2 as a rational number. So in the process of proving, what we're doing is we consider that root 2 is a rational number, and along the process, at the end, finally, we will prove that root 2 is not a rational number and hence it's an irrational number. We are going the reverse methodology. We are following the reverse methodology. Clear? So first of all, consider root 2 as a rational number. So what is a rational number basically? What is the
Numbers
rational?
in form P by Q. And numbers in form P by Q is not equal to 0.
Yes, any number which is in the form of P by Q and Q not equal to 0. That is a rational number, correct? So now since we consider this root 2 as a rational number, I can write it as root 2 is equal to A by B and B not equal to 0. Correct? Any doubts with this? Guys, respond. Any doubts with this?
No, ma'am.
Okay. Then
No.
cross multiply. If I cross multiply, I get A is equal to square root of 2 into B. Right? Is it not? The cross multiplication. Next, what we do is squaring on both the sides. Because we have to eliminate that square root. So I get A square is equal to 2B square. Correct? So what I do is I just change it. 2B square is equal to A square. I just swap the values. Clear till here?
Ma'am, can you explain squaring on both the sides? I didn't get the point.
Just have to square on both the sides. It's just that A square is equal to root 2 into B whole square, which is A square. This square and square root is cancelled. So 2B square is B square. So it is A square into A square is equal to B square.
Okay, ma'am.
Any
Understood.
other doubts?
No, ma'am.
Everyone.
No, ma'am.
Okay. So next, just now we learned that if P divides A square, then P divides A. Correct? The previous theorem. Theorem 1.
Yes, ma'am.
Correct? We are using that concept here. So this 2 divides A square. Then what happens? 2 divides 8. Correct? Yes or no?
Yes, ma'am.
Okay. So next what happens? I'll just replace it. So I'll write it as A is equal to C, where C is some positive integer. A is equal to 2C. We'll consider this. Now what I do, I'll substitute this value of A here. So I get 2B square is equal to, in place of A, I have 2C. So 2C whole square. So which is equal to 2B square is equal to 4C square. Correct? Which implies B square is equal to 2C square. Any doubts till here? Any doubts, guys?
No, ma'am. No.
We'll continue.
Yes, ma'am.
Okay. So this means, the meaning of this, B square is equal to 2C square means the 2 divides B square. Correct? Same like here. Same as this condition. Instead of A and B, you have got B and C here. Okay. So 2 divides B square here. Then what happens? 2 divides B as well. Correct? This is because theorem 1. Therefore, I can write that A and B have common factor. What is the common factor? That is 2. Because here 2 divides A and here 2 divides B. So both A and B can be divided by the same common factor, which is 2. Correct? Right?
Yes, ma'am.
So if you consider any rational number, this shouldn't have the same common factor, A and B. And initially we consider A and B as a prime number. Because in theorem 1, we use P as a prime number, right? So for a prime number, the factor should be the number itself and 1. We cannot have any other number as their factors, isn't it? But here we have, for A and B, the common factor is 2. Isn't it contrary to the statement which we have assumed here? Yes or no?
Yes, ma'am.
So whatever the assumption we have taken, that is false. So what assumption we have taken here? The assumption we have taken is root 2 is a rational number. So we prove that the assumption is wrong, which means root 2 is a irrational number. Okay. Clear with this?
Yes, ma'am.
Just make a note of it. So these are the very 2 important theorems, and you can follow the same procedure. Instead of root 2, you may get root 3, root 5, root 11 in your exams. Okay.
Okay.
You have to follow the same procedure. That's it, nothing else. Only thing you have to change here is assume, instead of this root 2 here, assume root 3 as a rational number. That's it. Everything else still remains the same.
Yes, ma'am.
Instead
Yes,
of
ma'am.
Instead of root 2 here, you get root 3, and instead of 2 here, you get 3, like that. Okay. That's the only change. Apart from that,
Okay, ma'am.
all the steps are same. Done?
Okay, ma'am. Yes, ma'am.
Okay. So this is the end of this chapter. So now what we do is, Puneet, are you there? Puneet? Puneet is not there. Puneet, can you hear me? asked me, you told me that you have got few doubts regarding few questions, right? Hello. Puneet? Puneet, can you hear me? Okay. Anyway, this. Okay. Do people, do you have any doubts with this? Others, Arpita, Shrikar,
No, ma'am.
No, ma'am.
Pawan.
No, ma'am.
You just have
No,
to,
ma'am.
what I suggest you guys is just write and practice the theorems. You will understand better. Okay. Fine? Okay. So next, we'll
Yes,
just
ma'am.
Ma'am,
ask you questions with what? Did anyone tell anything?
ma'am,
Yeah?
ma'am, I joined like 5 minutes late because the ma'am, the meeting password was actually changed. I'm not sure. I talked to Ashok sir about this like about 2 weeks ago. I typed in roots, but they said it was incorrect password, so I had to take another password from Ashok sir to note it down.
Sorry, I didn't get you, Shrikar.
Ma'am, you know the what do you call it? The meeting password when you have to log into the this room
Okay.
when you enter your password. And that was actually changed for me, I guess. I typed in roots, but the same thing happened like about 3 days ago when I was attending when I had attend Sachit sir's class. But they also the same thing happened, so that is why I was like about 5 minutes or 10 minutes late.
Okay, no problem. That's fine. And what are the topic like we have covered in that time? Anyway, like video will be uploaded. You can just go and check the video. Okay. Yes. Fine. Okay, we'll solve the question what your friend Puneet had asked. Okay, and that will help others, I mean, two people as well. Okay. The question, we just let me check. Okay, yeah. The question go like this. Will go like this. Show that any positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is some integer. Okay, so this is the question. Show that any positive odd integer is of the form 4q plus 1 or 4q plus 3, and that q is some positive integer. Okay. So first of all, what we'll do is we will assume a positive odd integer. Let us consider a. Let us consider a, and that a is a positive odd integer. Okay. So a is a positive integer, and we'll consider b as 4. Because here in the question, they are giving b. Okay, and according to the Euclid's division algorithm, what we have is a is equal to b cube plus r, and r is less than 0 less than b. Correct? So according to this, my r value should be less than 4, greater than or equal to 0. Correct? So therefore, r can either be 0, 1, 2, or 3. It cannot be 4 because R should be less than 4, not equal to 4. So I take up the value R is equal to 0, 1, 2, 3. Okay. Correct? Now what I do, I just apply these values here. I have A is equal to B plus R. Correct? I'll apply R as 0 here. So A is equal to 4Q plus 0, which is 4Q. Correct? Then let's put R is equal to 1. Then what I get? A is equal to 4Q plus 1. Then I put R is equal to 2. Then what happens? A is equal to 4Q plus 2. Then put R is equal to 3. What happens? A is equal to 4Q plus 3. Correct? And where in here, Q is considered as quotient. And you people already know that, and R is a reminder. Right? So here, since we consider A as a positive or integer, A is positive. Correct? So since A is odd, A cannot be 4Q and A cannot be 4Q plus 2. Correct? Because if you put any value to Q, then what happens, since 4 is an even number, if you multiply any number to an even number, you will always get an even number. Correct? That is why A cannot be 4Q and A cannot be 4Q plus 2. So what are the remaining values you have here? A can be either 4Q plus 1 or A can be either 4Q plus 3. That's it. Therefore, any odd integer, okay, it can take up the form 4Q plus 1 or 4Q plus 3. Clear with us? Very simple.
Yes, ma'am.
Want me to repeat again?
No, ma'am.
Pawan, any doubts? So this theorem, what we have used here is, this is Euclid's algorithm. If you don't remember this, you can't solve this problem. Okay. Current, any doubts?
No, ma'am.
Mohammed? Arpita?
No, ma'am.
Okay. Fine. Have a note of this. If people made a note of it?
Yes, ma'am.
Okay, fine then. So class will get over in another 1 minute. Okay, you people can take a break for 5 minutes and come back. Fine. And in the next session, we will solve the questions similar to this and also 2 other questions. Okay.
Okay, ma'am.
Come back after 5 minutes, guys. You people can now take a break.